This is section 7.3, example 1. I'll just go through their example. And I think this is the best way to talk about that shell method is through examples. And so what they would like is you're given that y equals x minus x cubed. And we would like to take the area between that and the x-axis. Okay, so that will look something like this, where that's a 1, that's a 0, that's our area. And we would like to revolve that around the y-axis. And the thing is, doing that, it gets kind of messy. We could use our disk method, or actually washer method, right? I could have a washer that has, that inner radius, that outer radius, but that looks a little messy. And so, drawing it again here, there's 1, there's 0. It might be a little easier to, take slices this way, rotate them around, and make these shells. And because, if I do that, the radius of each shell is pretty obvious. The radius of each shell is just x. The height of each shell is just y, or x minus x cubed. And so at that point, again, that area of each shell, when I flatten it out, it's going to have a radius of x in this case, so it'll be 2 pi x, and the height will be our y equal x minus x cubed. And so I just want to add up, a bunch of those, so I'm going to go from 0 here to 1. And so this is an integral from 0 to 1. My area, 2 pi x, again, that width times then this height, so times x minus x cubed, and then times the thickness of each little tin can thing, dx. And so I probably, to do this easiest, I want to multiply through by the x, so I'll just move out the 2 pi, and I have an integral from 0 to 1 of x squared minus x to the 4th dx. And so this is 2 pi and times x cubed over 3 minus x to the 5th over 5. And that's from 0 to 1. Placing a 0 in there, I get 0, but putting the 1 in, I get 2 pi times 1/3 minus 1/5. They seem to like that a lot. So that's 2 pi times 5/15 minus 3/15. So that leaves 2/15. So I get 4 pi over 15 for that example. Okay. So again, it's a matter of visualizing those tin cans and thinking about them flattened out. We had a radius x, so we needed that. So 2 pi x, or 2 pi times the radius, and then we needed the height of that tin can to make that piece. But once we do that, we can place it into this integral and get our answer of 4 pi over 15. Okay, or a little less than 1, since pi is 3.14. Okay, so there's example 1.